You are looking at a space experiment that represents almost 20 years of planning and execution. This is LDEF, the Long Duration Exposure Facility. Developed in the 70s and deployed in the 80s, by 1990, this 30-foot long, 11-ton satellite held the secrets of space exploration and habitation that would take humans well into the 21st century. And incredibly, we almost let it all burn up. As early as 1970, the plans for the space shuttle were well underway, and scientists were both excited and inspired by the opportunity to not only place large objects in orbit, but also bring them back and study them. The Meteoroid and Exposure Module, or MEM, was proposed as the first space shuttle payload. This large cylinder was intended to help spacecraft designers get a clearer understanding of meteoroid hazards outside our atmosphere. Placed in orbit by the shuttle, the large surface area would spend several months collecting meteoroid data before being retrieved and returned back to Earth for analysis. In 1974, the project was renamed the Long Duration Exposure Facility, or LDEF, and meteoroid research became just one of the goals, as the mission profile expanded to include multiple types of experiments based around long-term space exposure. Construction of LDEF began in 1976. Unlike the original cylinder concept of MEM, LDEF was designed with 12 sides to accommodate 72 flat experimental trays. There was also 14 additional slots housed in the two end frames. In 1978, after 2 years of fabrication, the aluminum framework and its internal magnetic stabilization system was complete, but its ride to space wasn't. Thus, the bus-sized satellite was placed in storage to await the start of the shuttle program, which at this point was already a year behind schedule. While originally intended as the first shuttle payload, mission priorities and scheduling changes left LDEF on the sidelines as shuttle flights began in April 1981. Finally, in June 1983, LDEF left the Langley Research Center in a special air-conditioned container and traveled by water to the Kennedy Space Center. Pre-launch preparation began in November 1983, as experiments from around the world arrived at KSC to be processed and installed aboard the aluminum frame. While more than one-third of the trays still consisted of meteoroid and space debris impact collectors, the facility included 57 diverse space exposure experiments. In March 1984, the now 21,000-pound satellite was carefully placed in a payload canister and prepped to meet the Space Shuttle Challenger waiting on Pad 39A. Transported vertically to the launch site, the payload canister was lifted into the rotating service structure and then transferred over to the Challenger's cargo bay. The first satellite specifically designed to be orbited and brought back to Earth was now ready for launch. On April 6, 1984, STS-41C lifted off from Cape Canaveral. NASA's 11th Space Shuttle flight was a mission with two bold objectives. The first represented the culmination of almost 15 years of preparation and planning, the orbital insertion of the Long Duration Exposure Facility. And the second was something that had never been done before, the capture, repair, and redeployment of an active satellite. On April 7th, after reaching an orbit altitude of 257 nautical miles, the astronauts of Challenger began preparations to deploy their 30-foot-long payload. The placement of the Long Duration Exposure Facility into orbit was a task that required precision and skill. It was designed to fly in a stabilized orbit at an inclination of 28.4 degrees, with one end always pointed at the Earth. Thus, care had to be taken that no movement or forces were transferred to the satellite during its release. Additionally, after deployment, moving away from LDEF was a slow and controlled process, being sure not to contaminate the experiments with the shuttle's maneuvering jets. Fortunately, the whole procedure went off without a hitch, and the Challenger crew moved on to perform a successful capture and repair of the Solar Max satellite before returning to Earth on April 12th. With the Long Duration Exposure Facility now safely in orbit, the scientific community began planning for the bright future of this exciting program. Designed to be reusable, the hope was to run regular LDEF deployments on a yearly basis. By September 1985, 42 companies had expressed interest in placing commercial experiments aboard subsequent launches. But before that could happen, LDEF and the shuttle program had to prove it could finish the mission. The shuttle Discovery was originally intended to retrieve the satellite in March 1985, but the schedule slipped as other missions were given priority. At the time, it didn't seem like a big deal. LDEF's purpose was literally long-duration exposure, so really staying in orbit a bit longer was just an opportunity to collect more data. Unfortunately, the events of January 28, 1986 made that delay indefinite. The Challenger disaster and subsequent investigation grounded the shuttle fleet for 32 months. When the program restarted again in September 1988, the backlog of missions meant LDEF was not very high on the priority list. But after almost 5 years, the duration of LDEF's stay in orbit was starting to become a problem. Solar activity was reaching the high point of its 11-year cycle, heating the Earth's atmosphere and causing it to expand. This in turn was increasing drag on LDEF and causing its orbit to decay more quickly than originally anticipated. Despite this fact, the retrieval launch dates continued to slip, while 5 other missions flew during 1989. Finally, Space Shuttle Columbia was reconfigured for LDEF recovery and scheduled for a December 18, 1989 launch. Calculations showed that by mid-January, the satellite would be too low to retrieve, and by March, 69 months of irreplaceable data would be burning up in the atmosphere. In spaceflight terms, the timeline was getting pretty tight. When the December flight was scrubbed due to unfinished launch pad modifications, fear that LDEF would be lost was becoming very real. The January 8th rescheduling represented the final possible week of the launch window, and it was aborted due to weather. Finally, at 7:35 a.m. on January 9th, 1990, STS-32 lifted off from Pad 39A. In command was Dan Brandenstein. A veteran of 2 previous missions, he had also been training for LDEF retrieval since before the Challenger disaster. On the morning of January 12th, Columbia rendezvoused with LDEF at an altitude of 175 nautical miles, and then began the slow approach to narrow the distance between the 2 spacecraft. After being captured by the Canadarm, a 4-hour photographic survey was done of the entire satellite. This was to ensure that any effects caused by retrieval and landing could be differentiated from the data gained during the almost 6 years of space exposure. Additionally, the photos were a backup in case the 11-ton facility was unable to be stowed properly in the cargo bay and had to be left behind. During this surveillance, the crew joked that they noticed something strange and transmitted this image back to mission control. It showed the LDEF completely overrun by tomato vines. This was in reference to one of the onboard experiments that involved storing seeds in space with the goal to germinate them later upon the return to Earth. But we'll talk about that more later. Fortunately, after the inspection, the long-duration exposure facility was able to be secured safely inside the shuttle, and on January 20th, Columbia glided in for a night landing at Edwards Air Force Base. As an added challenge to finish off this important mission, Columbia was 5 tons heavier than any previous shuttle landing. Also, transporting LDEF actually shifted the orbiter's center of gravity forward from its usual position. This required Brandenstein to maintain sufficient speed after touchdown in order to avoid slamming the nose gear into the ground. Rolling to a stop at 1:36 a.m., the crew actually set a new shuttle mission duration record of 10 days and 21 hours. With LDEF still safely stowed inside, Columbia was ferried to the Kennedy Space Center atop a 747 shuttle carrier aircraft. Upon arrival at KSC, the precious payload was carefully removed from the orbiter, and the 4-month-long process of inspection and documentation began. Even though it had originally been intended to be redeployed with new experiments, the unplanned 5-year and 7-month duration of the mission led to the LDEF structure itself being treated as an experiment. Over 40,000 impact features were identified across the entire satellite, the largest being a crater 5.25 millimeters in diameter, surrounded by a damage area spanning 5 centimeters. Damage of this scale really highlights the dangerous hazards spacecraft face outside our atmosphere, especially when you find out it was likely caused by orbital debris smaller than a millimeter and would have cut right through a typical satellite skin. By the end of March 1990, all the trays had been removed, examined, and then delivered to their owners, where in-depth analysis would continue over the next few years. The amount of information obtained from these 57 experiments was enough to host 3 post-retrieval symposiums, where hundreds of LDEF researchers and data users from around the world gathered to share their findings during multi-day conferences. But the experiment that really captured the general public's attention was a simple one: observing the effects of outer space on seeds. Over 12 million tomato seeds were flown on LDEF. Upon their return, they were packaged with control seeds that had never left Earth and then delivered to more than 40,000 schools. While the experiments did not result in any drastically altered plants, it did prove that seeds can survive in space for long periods of time. And interestingly, the space seeds were found to germinate more quickly than their regular Earth counterparts. Even now, over 40 years later, some of these seeds still exist, as seen in this Reddit post I found of someone growing space tomatoes in 2022. At its heart, LDEF really demonstrated what the US Space Shuttle program was all about: the ability to precisely place large satellites in orbit and then return later to retrieve and bring them back to Earth. The long-duration exposure facility may have only flown once, but its 20-year journey from inception to last-minute capture provided a collection of unprecedented data that would eventually help engineers select the best materials to build the International Space Station, Mars rovers, and other long-duration spacecraft. Also, the LDEF mission lives on with MISSE, the Materials International Space Station experiment. Since 2001, the MISSE series has tested some 4,000 material samples and specimens in order to demonstrate their durability in the punishing environment of space. Here at the That Happened channel, I like to highlight incredible aviation and spaceflight history. If you enjoyed this video, please subscribe and check out my other content, like this documentary about Don Lind, an astronaut that had to wait 19 years to fly to space.